Hey everyone and welcome back to my channel. I'm Anish and today we will solve the most important questions from diode circuits. I know many guys get confused in this topic that which diode will be on and which diode will not be on, and there are very good questions that can be framed from this which can come in your written test, right? On your campus placements or in gate as well. These type of questions can come in gate as well. In interviews normally they don't ask from these topics, but they can also ask from these topics as well. Mostly they ask from those RC and like MOSFETs, but for written test, right, these are the most important questions that you should be able to solve if you want to clear written tests of important companies. Also, you can follow this playlist where I am solving the most asked questions for written test and gate, and you can follow this playlist where I have tried to solve the interview questions which can be asked in analog domain. Okay, so that was basically introduction, and you can check out our website prepfusion.in where we have provided comprehensive courses on analog domain for placements. Also there is a course for analog electronics for gate, especially there is a course for engineering mathematics for gate. Also more courses will come, so you can keep an eye on our prepfusion.in website. Also you can subscribe to our other channel, that is Prepfusion. Okay, there we post a lot of free content there, so you can follow that as well for your gate and placement preparation. So keeping that aside, let's start with this first question. So in this question, right, they want us to find the node voltages V1, V2, V3, V4 and the currents through each of the diodes. So how should I go about this question? Whenever a question like diode type of question comes, right, first you have to have a good level of intuition. What do I mean by intuition? What do you want to assume? Do you want to assume that this diode D1 will be on or off? Do you want to assume that this will be on or off, or this or this? Okay, obviously like there isn't any fixed method to this. Okay, this is just an intuition, and your intuition might go wrong. Whatever you have guessed, right, that might go wrong, and if it goes wrong you have to reverse the state. What do I mean by that? I will explain. So let's first take a guess. So if I assume that all of these are off, right, if I assume all of these are off, then what do I see is, if I start from this diode E1, I see that if the current through this is 0, this is negative, so N is connected with negative and P is connected with a positive. So I can assume that, okay, this diode can be on. So we'll assume that D1 is on. D1 is on. Okay, this is my assumption. This can go wrong as well. How can it go wrong? If D1 is on, right? So first of all, if a diode is on, then the anode to cathode current should be greater than 0. If a diode is off, I will say here the states, if it is on and if it is off. If it is off, then the anode to cathode voltage should be less than 0. Okay, so these two cases must be certain if this is on or off. Okay, this is for an ideal diode. For a practical diode, there will be cut-in voltage and like all those things will be present, right? I'm just talking about an ideal diode for now. So I have assumed D1 is on, and why have I assumed that? Because like I can see that P is connected to positive and N is connected to negative, so I can assume that if VAK is greater than 0, when this is off, that means it cannot be off, it has to be on. Okay, now if this is on, right, then some positive potential is coming over here to this N, and again some positive potential is here to this, right? So what I will see is, like I will assume that through here and through here, I will assume that this diode is off, because both ends are positive. I cannot say anything conclusive. I will assume D2 is off. These are just assumptions. This can go wrong as well. So I will assume D2 as off. Okay. Next, what I will assume is this is positive. Okay, and this is negative again. So this is D3 is on. Okay, so I will assume D3 is on. And so for D4, right? So for D4, I can see that N is connected with and grounded, and this P is connected, if this diode is on, is some positive value, so I can assume D4 is positive. So all of this can go wrong. My first guess can go wrong horribly. Okay, but let's see if it is wrong or not. How can I know if it is wrong? I have assumed D4 is on, and if D4 is on, and if the current through the diode is negative, is not greater than 0, and if the cathode current is not greater than 0, then my assumption was wrong. Okay, so we have to compute all this, we have to calculate all this. So I will copy this and paste this over here. Then I will delete all this diode and just replace them with their assumed states. So this D1 was on, so this is the ideal diode, so I will replace it with a short circuit. Now D3 is on, so this will be also replaced with a short circuit. D4 is on, so this will be also replaced with a short circuit, and D2 is on, D2 is off, so this will be just a open circuit, right? This is open circuit. Now from this I can say what is my V1. So the current through this is same, right? This diode is off, so current through here is 0. So this 4 and 2.5 are in series, so I can directly find the current. So what is this current? So this is this ID1 current, right? Diode 1 current. So what is ID1? ID1 is simply 6.4 minus of minus 4.3 divided by 6.5 kilo, right? 6.5 kilo. So if I compute this, just hold on, I will just get the calculator. So if I compute this, it will be somewhat around, I have already computed it, 1.65, but still let's do it again. 6.4 plus 4.3 divided by 6.5. Yeah, it will be 1.64, or I can assume this as it will be 1.646 milliamperes. Now this is my ID1, and ID1 comes out to be positive. So this guess was correct. Okay, this guess was correct. But even if any one of the guesses is wrong, again I have to solve the circuit again, okay, with that correct state. Then again all this information will change. What do I mean by this? I will explain later on. So ID1 is positive, so this guess was correct. So what is V1? So we have to find the V1 voltages as well, right? V1 will be what? Simply that, like 6.4 minus this drop, right? 6.4 minus this drop. So it will be 6.4 minus 1.641 into the resistor, it's 4. So it is times 4 minus 6.4. So it will be minus 0.1846, which is equals to V2 as well. So my V2 is some negative value. Okay, V2 is minus 0.1846 volts. Okay, so that is fine. So now let's compute our this current, right? This current. So this is the what? ID3 current, right? Diode 3. This was a diode 3. So what is this current? So this current is 6.4. Again, these two are in not series right now. Why? Because some current will go here as well. So these two resistors are not in series now. So how do I compute? So what you can do is, this potential is what? This potential is 0, right? So current through this is what? 6.4 divided by 2.5k. Okay, so current through this will be 6.5 divided by 2.5k. So which will be, so ID3 6.4 divided by 2.5k, right? So it is 2.56 milliamperes. Again, what do I see? It is greater than 0. So my assumption was correct that the diode D3 will be on. Okay, diode D3 will be on. Now what about the voltage V3? So how can we find the voltage V3? So for V3, right, V3 is grounded here. So V3 and V4 are 0. V3 equals to V4 equals to 0 volts. Now one thing to notice, I told you, right? I told you that D2 is off. D2 is off. If D2 is off, then the anode to cathode voltage should be negative. Then only it will be reverse bias and diode will not be on. So is that true? So this is the anode voltage of diode D2 and this is the cathode voltage. Cathode voltage is 0 and V2 is some negative value. So VD2 anode to cathode equals to V2 minus V3 equals to minus 0.1846 volts, which is less than 0. So our assumption that diode D2 will be off is correct. You don't even know how happy I am that all my assumptions are going correct. Okay, and they can go wrong as well, and I will take an example where it will go wrong and there we'll see what modifications we need to make. Okay, so I'm very happy now. I just need to check the state of the last diode D4. All the three assumptions got correct now. So what about the last one? So here, right, what I am observing is this resistor, one end is grounded and other end potential is minus 4.3. So I can again compute the current. Okay, there is some current Ix. So what will be Ix current? Ix will be 0 minus of minus 4.3 divided by how much potential is this? 5 kilo ohms. So 5k. So it will be almost 4.3 divided by 5. 0.86 milliamperes. Okay, 0.86 milliamperes. Now I also need to find this current ID4 as well, right? Because I have assumed that diode D4 will be on. Now if ID4 is greater than 0, what do we mean by greater than 0? That means if current is flowing from anode to cathode, then diode D4, whatever assumption I have took, that diode D4 is on, that is correct. Let's check. So how do I find out ID4? Basically, we will apply KCL at this node V4, right? So ID3 is coming, Ix current is going out, and ID4 is also going out. So ID3, just hold on. ID3 equals to Ix plus ID4. So I know Ix, I know ID3. ID3 is how much? ID3 is 2.56 milliamperes minus Ix is 0.86. Okay, so it is 1.7 milliamperes. So my direction of ID4 I have taken as from anode to cathode, and this is coming out to be greater than 0. So obviously if this is coming out to be greater than 0, that means what? That means that whatever assumption I have taken, it is correct, that D4 will be on. That assumption was correct. So all the 4 assumptions are correct, only then the overall solution is correct. If even one of the assumptions were wrong, then I have to solve the circuit over again. Okay, what do I mean by that? I will explain. Okay, so the answer to this question will be that D1 will be on, D2 will be off, D3 will be on, D4 will be on. V1 voltage is minus 0.1846 equals to V2. ID1 current to the diode 1 is 1.646 milliamperes, and V3 and V4 both are 0 volts, and ID3 is 2.56 milliamperes, and ID4 is 1.7 milliamperes. This is the answer. Okay, now let's come to a case where I take the wrong guess. Let's assume that, okay, I took a wrong guess. I assumed D4 as off. Okay, I assumed D2 as off and D4 as off as well. D1 and D3 are on. Okay, let's take that case. So if I take that case, I will just copy this. Okay, just copy this. So I have assumed D4 as off. So if D4 is off, that means this will be open circuit, right? This will be open circuit. That is my assumption. Now, what will happen is these two resistors will come in series now. If these two resistors will come in series, because the current through this will be same, because through here the current is 0. Through here the current is 0. So I want to find out this potential V4. If I find out this potential V4, then what will I do is, I know the cathode potential of diode D4, which is 0 volts. I just need to find out V4. Okay, then I can conclusively say if the anode to cathode voltage is negative, then I can surely say that this D4 diode will be off. Let's see if it is off or not. Okay, so how to find out V4? Simply, what you can do, you can find the current through it here, or you can simply apply KCL as well. How do you apply KCL? What you can do is, just hold on. Yeah, I can apply KCL at this node. So it will be V4 minus 6.4 divided by 2.5k. Okay, basically I'm just equating the currents. V4 minus of minus 4.3 divided by 5k equals to 0. So from this, what is my V4? So V4 will be equals to, I will just quickly compute this. it will be 6 point, just hold on, minus it will be plus, right? So 6.4 divided by 2.5, then minus 4.3 divided by 5. So it is coming out to be 1.7 volts. Okay, so it is coming out to be 1.7 volts. If it is coming out to be 1.7 volts, what does it mean? Just hold on, if I am computing everything correct over here. V4 minus 5. Okay, so this is 2.5. Yeah, 6. I just compute it 1 second to just cross verify. 2.5 minus 4.3 divided by 5. Yeah, 1.7 volts. Okay, so if this is 1.7 volts, what is my anode to cathode voltage of diode D4? It is V, sorry, not 4, sorry, this is, yeah, this is 4. Yeah, V4 minus 0, because this is grounded, right? This potential is grounded. So V4 minus 0, which is equals to 1.7 volts, which is greater than 0. But I have told you, right, for a diode to be off, its anode to cathode voltage must be 0, must be less than 0. It must be reversed biased. But here I am seeing that if I assume this diode as off, I'm seeing that the anode voltage is higher than the cathode. That means the diode has to turn on, because it will be in forward bias mode if you have studied about the construction of a PN junction diode. So my assumption was wrong. If my assumption is wrong, I have to change this. What I will do? I will make this to on, right? So hence D4 has to be on, as it is forward biased. Again you will solve the whole circuit. Again you will see that even if one of the states you are getting is wrong, then you have to resolve again with that state corrected. Okay, and keeping the other state as it is. Now you might say, how many times will you have to do? You have to do this if you are very unlucky, right? If you are very unlucky and if your intuition is really bad, you have to do this 2 raised to power n. What do I mean by n? N means the number of diodes. And how did this formula came up? This formula, simply if you want to derive, right, simply you can see from here. Okay, from this question, how many diodes do I have? 4 diodes. How many states can this diode take, on or off? 2. So I can have 2 cases. If you have studied PNC, you will know this very good. Well, how many states can this diode have? Again, on or off. So again, times 2. This can be on or off. This can be on and off. Okay, this and this, again, and this, right? Everything is anding here, because all of this, there is no or here, there is and. So if this is and, right, there will be a multiplication sign. Okay, so there is a multiplication sign, so everything will get multiplied. Again, D3 can be on or off, D4 can be on or off. So it is 2 raised to power 4. So each diode can have 2 states. That's why overall the circuit can have 2 raised to power 14 cases. But out of these 2 raised to power 14 cases, only one case will be valid. Okay, only one case will be valid. So if you are very unlucky, right, you will like take all the other 15 cases, and then you will get back to your 16 case. You will obviously find out the correct one. Okay, but it will take you more time. But if your intuition is very good, right, it may so happen that in the 3rd try or the 4th try you are getting to the right stage, because you have assumed the most of the diodes as a correct state. Only 1 or 2 diode you have assumed wrong. So that's where intuition comes in, right? It helps you lower your computation time in gate as well. It will just take you lower time to solve the overall circuit. Else, just think, there are 16 cases. If there are 5 diodes, there will be 32 cases. Okay, so your intuition must be very good. Okay, else you will just be lost in the computation. So this was one of the very good question. Okay, this can come in written test. Okay, and I also told you what can go wrong. Okay, I've also told you that and how to rectify it. So these are the number of cases. This is the number of cases. Now let's solve this one. This one is also a very good question. So here diode has a forward drop of 0.7 volts. Answer the following. Determine current and voltage for the 3 circuits. So we have given 3 circuits with resistor, capacitor and inductor and a diode, and we have to find the current and voltage, right? Voltage V. Okay, voltage V. Okay, so let's solve this first, then I will solve the second one. So second one is also a very good question. So first one, right? So here this is, first of all, this is not an ideal diode. We have a forward drop of the diode. Okay, so now for this question, right, we have to find out V and I. So I will just copy this one. Okay, copy this one and paste this over here. So first thing, what do I notice is this is not an ideal diode. So for this diode to be on, right, for this diode to be on, the anode to cathode voltage must be greater than 0.7 volts, right? It has to be greater than 0.7 volts. Then only this diode will turn on. Now, is it possible? Yes, right? Here I have 5 volts. So it is definitely possible that this diode will turn on because I have higher voltage than the turn on voltage of this diode. So this diode will definitely be on. That, like that, I can tell from intuition. And if you want to prove, you can prove. How you can prove? You just copy this and paste this and assume that diode is on. Okay, because if you assume this is off, right, if you assume this is off, what will happen? Current through this is 0, current through this is 0. Overall VAK potential will be what? 5 volts. Okay, which is greater than the on potential. Hence, it must be on. Okay, it is not negative, it is not lower than 0.7 volts, it is greater than 0.7 volts. Then diode must be on. So if diode is on, that means I can replace this with a voltage source basically, because this time it has a turn on voltage. This is not ideal anymore. So this is 0.7. Okay, now what is the current? Current is simple, right? Current is very simple. It is 5 minus 0.7 by 20 kilo ohms. So it will be almost 4.3 by 20, which is 0.215 milliamperes. Okay, 0.215 milliamperes. So this will be my current. Now what will be my voltage? So this question is very controversial because for finding out this voltage V, you have to assume a reference. Now if you assume reference in some other place, your answer will be different. Okay, but if they haven't given you any reference, right, where should you assume the reference? That is also a good question. So most cases you assume the negative terminal of the battery as the reference. So what do? You ground this. Then only you will be able to find the potential at a point. Remember, right, we can only find potential at a point if we haven't given a reference. Else we can only talk about the potential difference. We cannot talk about the potential at a point. We can talk about potential difference between 2 points, but we cannot talk about potential at a point if reference is not given to us. Okay, and most cases we assume reference as the negative terminal of the battery. So this I will ground. Now what will be V? You can find out V in both ways. You can either subtract this drop from this 5 volts or you can add these two drops. So both ways your answer will be same only. So we'll compute this. V will be 5 minus 0.215 milliamperes into 10, or what you can do, you can add the two drops in the bottom, 0.7 plus 10 times 0.215. Okay, so both of them will be same only. So this will be 2.15, which is 2.85 volts. 2.85 volts. Okay, so your V answer will be 2.85. Okay, so for the first question, the answer to the voltage will be 2.85 and the current is 0.25 milliamperes. So let's take the second one. In case of capacitor, now in case of capacitor, right, transients will be involved. Now what will happen is that if I assume at t equals to 0, if they have mentioned nothing, obviously I will assume that my VC 0 minus is 0 volts. Capacitor initially has no charge. So if capacitor doesn't have any charges, and if I see here that this is 0 potential, right, and I have already told you that we'll assume this as reference. Again, this is 0 potential, and if we assume this diode as off, what will happen? Again, there will be a total 5 volt drop across it. A total of 5 volt, sorry, not drop. A total of 5 volt will be coming across this diode, which will again make this diode on because it is greater than the turn on voltage of the diode, that is 0.7 volts. Okay, so VAK is greater than 0.7 volts. So diode will be on. So if diode is on, what will happen? This will act as a simple RC circuit, but there is a difference to it. What is the difference? I will explain. So this will not be short circuit because I have to replace this with a turn on voltage of the diode. So what is the turn on voltage of the diode? 0.7 volts. So now here what will happen? Finally, what will the capacitor try to reach? So at steady state, what happens to the capacitor? The rate of change of voltage goes to 0. If the rate of change of voltage goes to 0, that means the current is 0 at steady state. If current is 0 at steady state, what will be the potential across this capacitor? The potential across this capacitor, this drop will be 0. That means the potential across it, VC infinity, will be 4.3. Okay, because 0.7 will be dropped from here. Okay, so VC infinity will be 4.3 volts. Okay, so will this diode ever be turned off? Tell me in the comments below, will this diode ever be off? Tell me. If it will be off, then tell me the time instant at which this diode will be off. Okay, tell me in the comments below. Like that, I will also know that you are watching till the until this end. Okay, and if you are watching until here, please do hit the like button also. Okay, so yeah, thank you. Like that also helps me. That's makes me do more and more videos, record more and more videos. That appreciates me. Okay, so now what will be the equation? The equation of capacitor voltage will be simply, it is going from 0 to 4.3. So VCT will be simply 4.3 1 minus e raised to power minus t upon tau. And what will be ICT? ICT, it is initially, what is the current? Initially there is how much of current? There is, if I write at t equals to 0 plus, if I draw this circuit at t equals to 0 plus, if I draw this circuit at t equals to 0 plus, what will happen? This capacitor will get short circuited. I will draw for both the states. I'm assuming you already know good transient, right? That's why I was not solving through so basics, but still let's solve it a bit basically. So this will be 0 volts. Okay, so initial current, right, at t equals to 0, and I will draw the circuit for t equals to infinity where my capacitor will be open circuited. So my capacitor is open circuit, I will be 0, right? So both cases, here what will be my I0? I of 0 plus will be simply 4.3 divided by 10 equals to 0.43 milliamperes. So initial current is 0.43 milliamperes. Now the final current is 0. So for a transient, right, we write the equation like this. This is the equation of I of t equals to 0.43 e raised to power minus t upon tau milliamperes, where my tau is what? Tau is R times C. You just multiply R times C, that is 10 kilo times 10 micro, that is 100 milli, and that is 0.1. Okay, 0.1 seconds. So this is my RC, right? Now this is how you solve. Now this is the current equation I have already wrote. They have asked us to find the current and the voltage. So I have already found out. But what about V? V will be what? V simply, you can write, you can find out in other ways as well, but I will use the simple method, that is V is equal to 0.7 volts, because here 0.7 volts is constant. It will always be there no matter what. Plus this VC, right? Plus this voltage VC. Okay. Plus this voltage VC of t. This is my V of t. So this time my voltage will be function of time. Previously it was constant, like for the resistor case. So I have already computed here VC of t. I will just add with it. So VC of t I will add. So this will be 5 plus, just hold on, this will not be 5 plus, this will be 5 minus 4.3 e raised to power minus t upon tau. Okay. So this will be my VC of V of t equation. Now let's do a quick sanity check. So here at t equals to 0, what is happening? T equals to 0, my V of t is 0.7 volts. Is it true? At t equals to 0, yeah, V of t is say 0.7 volts, because this is short circuited. So only this potential is present. Diode has just turned on, so it will give a voltage of 0.7 volts. At t equals to infinity, what is happening? This is gone. I have got 5 volts. T equals to infinity, this is open circuit. So what will happen is that this is grounded, right? This is grounded. So V potential, this drop is 0. So this whole potential is coming across this, right? This whole potential is coming across this. So V will be totally 5 volts. So again, it is correct. V will be totally 5 volts, or you can add from here as well, that VC of infinity is what? 4.3 volts. So it will be 0.7 plus 4.3, which is 5 volts. So like let's solve it for the inductor case, or what I will do is I will give you the homework as inductor, because that will like make this video long, but okay, let's do it anyways. Let's do the inductor anyways, because I will give you homework for the other case. So for the inductor I will do a bit quickly now. Okay, so for the inductor, how to solve? Let me take a new page. So here, right, again, if nothing is mentioned, I will assume that initial energy of inductor is 0, that is initial flux is 0, that is initial current across the inductor is 0. So if initial current across the inductor is 0, so it will act as open circuit at t equals to 0. Act as open circuit at t equals to 0. So if it acts as open circuit, what will happen? Okay, everything is gone. This is open circuit, right? So again, if this is open circuit, now what is the potential across the diode? The potential across the diode, this is grounded, is 5 volts, right? It is 5 volts. So if it is 5 volts, this current is 0. This is 5 volts, diode will turn on. So if diode turns on, this will give a potential of what? 0.7 volts. Turn on voltage of diode is 0.7 volts. Now after that, what happens? After that, basically this inductor, right? How much voltage across this inductor? 4.3 volts, some positive voltage. So current will increase. Current will increase slowly. Current will increase until what? Current will increase at steady state. What happens? The rate of change of current across this inductor is constant. If it is constant, the voltage across the inductor will be 0. It will become short circuited. So this is at t equals 0. I am not explaining much here, because I am assuming that you already are very good at transient. Okay, so I am not explaining much here. So this will be short circuited at t equals to infinity. So if it is short circuit at t equals to infinity, what is the current? What is the I of infinity? The I of infinity is simply 4.3 divided by 10, that is 4.3 milliamperes. So in the previous case, 4.3 milliamperes was the I of 0, but here it is I of infinity. So things are changed now. So how will I write the current equation? Again, the current equation, I of t will be, again, it will be a bit different this time. 4.3 1 minus e raised to power minus t upon tau milliamperes. What about my voltage? So what is VL of t? VL of t, if you observe here, that initially it was what? Initially here, right? Initially what was the voltage? If you just apply a simple KVL, you will get it as, like, my VL is like this, right? VL is like this, and VC was also like this. If I haven't mentioned the polarity is like this. Current is incoming to this. Yeah, so mention the polarity, else you will get confused. This is my VC of t. Okay, this is the polarity. So what is my VL of t? VL of t, initially the potential was 4.3, and finally it is 0. Like it becomes short circuit at infinity, e raised to power minus t upon tau volts. Okay, so like what is tau in this case? Tau is L by R. L is what? 100, I think it was 10 nanohenry, and R was 10 kilo, right? Okay, it is very small. Okay, I don't know why they give numbers like this. Must have been some mistake. Okay, so it will be 1 picosecond. Okay, 1 picosecond, that is 10 raised to power minus 12 seconds. Now what is my V again is 0.7 plus VL of t, right? So V of t will be 0.7 plus 4.3 e raised to power minus t upon tau. Now let's do a quick sanity check. So at t equals to 0, what is happening? This is 4.3 and this is 0.7. So at t equals to 0, what is the potential across here? There is open circuit, no current. So this whole 5 volts is coming across this. So yeah, at t equals to 0, potential is 5 volts, correct. At t equals to infinity, what is happening? This is short circuit. So only 0.7 volts is remaining. So V will be 0.7 volts, which is again correct through this equation. So like you should do a sanity check as well after solving the question that your solution is correct or not. Okay, so let's do another question. Like this time just the waveforms will be sinusoid, the B1, right? So they are telling us if the DC voltage source is replaced with AC of 1 megahertz and plus minus 5 volt peak to peak, then draw the waveforms V and I for all the circuits. So I will do this, I'll solve for only this simple R circuit. I will not do for capacitor and inductor. That is the homework for you. Else the video will go very long. I don't want that. So here I will just copy this. Okay, so yeah, I have already like drawn the waveforms. So input is something like this, right? I am dot omega t. I am not writing it in terms of frequency right now. So it will seem, right? It will same case. If my input was constant 5 volts, then it would have been like the previous case, but now it is a sinusoid. If it is a sinusoid, what will happen? So I'll do this a bit quickly. Okay, you try to watch it like twice, or if you are not able to understand, watch it twice, you will be able to understand it. So initially when my voltage is 0, no current is flowing, right? I will assume diode is off, no current is flowing. So what is the VAK? VAK is 0 and it cannot turn on. Why? Because for the diode to turn on, it needs a minimum potential of 0.7 volts. VAK should be greater than 0.7 volts, not on. Again, at 0.5, what is the VAK? This current, like I have assumed diode is off. So the potential across this diode is, this is grounded, just hold on, is 0.5 volts, right? Will the diode turn on? No, it is lower than 0.7 volts. It will not turn on. Now, if the potential is 0.0071, now VAK is greater than the 0.7 threshold voltage. Okay, so diode will turn on. So if diode turns on, current will flow. Okay, current will flow and potentials will change. Okay, so when will the diode turn on? The diode will turn on when my voltage is input voltage is 0.7 volts at that instant. Before that, diode will be off. So if diode is off, so I can like draw the current waveform. It will be 0. Okay, and until theta, and this theta is when my Vi equals to 0.7 volts, then only the diode will turn on, else the diode won't turn on. And the sinusoid is increasing. Okay, sinusoid voltage is increasing, hence the current will also increase, because after this diode is on, this is simply a resistor divider circuit. So simply, if it is simply a resistor circuit with a battery, so if voltage increases, current will also increase. Current will also increase, and it will increase just like the input sinusoid. Okay, it will just also be like a sinusoid, and again it will go to 0. When it will go to 0, I will explain. So here, what is the peak? When will the peak happen? When the input voltage is maximum. When is the input voltage maximum? 5 volts. So at 5 volts, what is the current? At 5 volts, the current will be 0.215 milliamperes, which we already solved here. So at 5 volts, the current will be peak. Okay, after that, the potential is decreasing, hence the current will also decrease. Okay, so this peak will be 0.215. This is in milliamperes. Fine. Now again, when will this turn off? When the input voltage is just lower than 0.7 volts, it will again turn off. Why will it turn off? Because again, the anode to cathode voltage will be lower than 0.7 volts. If it is lower than 0.7 volts, diode cannot turn on. The PN junction needs minimum 0.7 volts to turn on. So it will be off again. It will be off. Okay. So this angle will be pi minus theta, and again here Vi will be equals to 0.7 volts. Okay. So obviously in a sinusoid, right, it reaches twice 0.7 volts here and at here. So this value will be 0.7 volts. This is at theta, and this is pi minus theta. Okay. Now, what about the voltage waveform? Voltage waveform is a bit interesting here. So initially, if the diode is off, right? If the diode is off, so if I write this V potential, if the diode is off, then the current through this is 0. if the current through this is 0, so this ground, right, this comes over here, so this is also grounded. So one of the terminals, the cathode, is grounded, okay, and this current is 0, so this whole Vi comes here. So when the diode is off, right, when the diode is off, then Vo equals to Vi. So it will just follow the input. Okay, you can write the KVL equations, all those things. You will see it will just follow the input. So in this region, right, in this region, the diode is off. D off. Now what is happening in this region? In this point, at when the voltage is just equals to 0.7, so Vi equals to Vo, and when Vo is just equal to 0.7, then diode will suddenly turn on. And if diode suddenly turns on, what will happen is, like, there will be some drop here, and what will happen? This will just be a shifted sinusoid with 0.7. What do I mean by that? I will just prove you mathematically. So after 0.7, right, how will the circuit look? The circuit will look something like this. Oh no. This diode will turn on with a potential of 0.7 volts. So what will be the drop across this? The drop across this will be simply this drop, right? This drop will be Vi minus 0.7 divided by 2. Okay. And what is this? What will be this value then? So if I add this, right, so my V will be, I will add 0.7 with this. So I have just used potential divider rule, nothing else, right? Voltage divider. So it will be 0.7 plus Vi minus 0.7. So it will be Vi plus 0.7 divided by 2, or by 2 and by 2. So if you put Vi equals to 0.7, right, this satisfied, V equals to 0.7. After that, what will happen? This will follow Vi by 2 plus 0.7 by 2. So here, right, my slope has reduced. My slope has reduced. Previously, what was my V? My V was equal to simply Vi. I explained why. So slope was like a slope. What do we mean by slope? Basically the slope of this, right? So transfer function, slope of V over Vi. This was 1. Now slope has reduced. It is Vi by 2. So it will go a bit slowly now. It will increase a bit slowly. If my sinusoid is increasing like 10, what do you say? Sinusoid is increasing by 10, then this will increase by 5. So this will increase slowly. So the waveform will look somewhat like this. It will increase slowly, okay, and it will be peak at some point. Then again it will go, okay, and then again the diode will be off, and again it will follow the input. So here D is off, and in this whole region, right, in this whole region, my D is on, and then in this region as well, my diode will be off. And what is the maximum potential? The maximum potential will be when Vi is equals to 5. So it is 2.5 plus 0.35, which is 2.85. So this value will be 2.85. One thing, this is not to scale, okay, because what will be the issue is, I will just explain in a bit. I will just make this a bit smaller. Why, I will explain. So why am I making this smaller? Because diode is off for this, after this whole period, because after this what is happening, the input voltage is negative. It can never go above 0.7 because it is negative. So obviously diode will be off. I don't even have to think here. So diode will be off. So this will be something like this. It will totally follow the input, right? V will be equals to Vi. So yeah, like now it is up to scale, because Vi, the maximum negative peak it can go to is minus 5 volts. So in this whole region, okay, sorry, this needs to increase here. Yeah, fine. In this whole region, diode is off. And what are the values of time here? This time is what? Theta. This time is pi minus theta. And diode will be off here. This will be what? What will be the negative peak across the diode? It will be minus 5 volts. It will be minus 5 volts. So this is how you plot for the resistive case. Now for the inductive and capacitive case, I'm giving you this as homework. Now let's go on to, like, and so tell me in the comments what will happen also. Okay, so let's come back to this last question. So this last question is pretty simple, but just you have to understand one basic thing. One basic thing is diode can only, like, current through the diode can only flow in one direction, not in two. Okay, so again, diode has a, like in this question, diode has a forward drop of 0.7 volts. Determine the values of sorry, this time, right, diodes are ideal actually, so not 0.7. I will have to change the question. Diodes are ideal, else this question will go long again. Okay, like you could solve with that also, but the question will go long. So now, right here, diodes are ideal, and you have to find the value of current I, V1, V2. I is this current. Now what you have to understand is that current through the diode can only flow in one direction. So if I assume this is on, if this is on, current will flow in this direction, but this diode isn't, like, connected reverse, right? So current flow in this direction is not possible. So through this combination, current will never flow in this direction and in this direction. It is not possible, because if in this direction current flows, it is fine for this diode but not fine for this. This diode will be unhappy. This diode won't pass that current. If I flow in this direction, again same case. Here possible because both diodes are connected back to back. So if this diode says current is flowing in this direction, it is possible for this diode to flow in this direction. So fine. Now for this, again, it is possible if current flows in this direction. Again possible, right? Is it possible here? No. If this diode says current should flow in this direction, this diode is saying no, I cannot flow current in this direction. So A and D are simple. I will be 0. I will be 0. What about V1 and V2? If I is 0, right? So simply I can replace them with open circuit. So V1 will be simply potential divider. It is 10 by 6 into 2. That is 3.33 volts. Sorry, yeah, 3.33 volts, right? Not, sorry, 10 when it is 4 times this, right? 4, yeah. So it will be 6.67 volts. And what about V2? V2 will be simple 1 by 5 into 10. So it is 2 volts. So V1 minus V2 is not V1 and V2 are 6.67 and 2 volts. Okay, and I don't need to compute this anode to cathode, all those things, because current flow is not possible in this route. Okay, not possible. And for D as well, the answer will be same. Everything will be same, because this link has been off, so I will be off, and V1 and V2, all those things will be same. We don't need to compute it again. Okay, because this link is off, right? Because current flow is not possible. So I is 0. So now what about this B and C? So if I assume, so we have to assume here that this diode is on. If I assume this diode is on, and if the current flow direction is in this, like from anode to cathode, then my assumption is correct. If my I comes out to be positive, then my assumption is correct. Okay, and if this assumption is correct, then this is the combination is not possible. Again, this diodes will be off. Why? Because if I assume these diodes should be on, then my current direction is this. If my I has to come out as negative, then only current flow will be from anode to cathode. If I comes out to be negative, then this is possible. But here, if this is already established that I will be positive, then this case is invalid. So again, here also diodes will be off. We'll see. So if I assume here diodes to be on, so we'll replace them with simple short circuits. Okay. So finding the current through here is a bit tricky. For you to find the current, right, you have to find the currents near this node. Okay, you cannot find the current through a short circuit simply. You have to find the currents through the other nodes. Okay, other nodes and branches. So how do I find? So this time, right, V1 equals to V2. So if V1 is equals to V2, so these two are in parallel, these two are in parallel. So if these two are in parallel, then I can draw a equivalent circuit. So what is the equivalent circuit? 4 parallel 2. 4 parallel 2 is 4 into 2 divided by 6. That is 4 by 3. So this will be 4 by 3 kilo. This will be how much? 4 by 5 kilo. Okay, why? Because 4 into 1 divided by 4 plus 1, 5. So these two are in parallel and this is ground. Okay, this is 10 volts. So what is this potential V1? This V1 potential is simply again a voltage divider, that is 4 by 5 divided by 4 by 3 plus 4 by 5, that will be 4. I will take common, 1 by 3 plus 1 by 5, that is 8 by 15 equals to so what will happen is that this will be 3, this will be 2, this will be 5, this will be 15 by 4. Okay, 15 by 4 volts. So V1 comes out to 15 by 4 volts, and again I will come back to this circuit now. Okay, because I need the current here. Okay, I cannot find the current has been hidden here, both the nodes are same here, so current has been hidden here. So this potential is 15 by 4. So what is this current? What is this current? So V1 is let me name this current as I1 and let me name this current as I2. So what will be my I1? It will be 10 minus V1 divided by 2 kilo, right? Simple KCL. So V1 is 15 by 4, so it will be almost if I just compute this, 10 minus 15 by 4 is 3.5, right? 3.75, 3.75, 3.75. So 3.75, 10 minus 3.75, which is 6.25. 6.25 by 2 kilo. Okay, this is my I1. What is my I2? I2 is V1 by 4. V1 by 4. So it is 6.25 by 4 kilo. So if I want to make the denominator same, so I will just, for simplifying my computation, so you always don't need calculators, right? You can solve without calculators as well. So if I multiply 2 on both sides, numerator and denominator, this will be 12.5 divided by 4. So if I apply simple KCL at this node, what will happen is that I1 equals to I2 plus I. So I will be equals to I1 minus I2. So I1 is 12.5 divided by 4 minus 6.25 divided by 4. So it is 6.25 divided by, this is kilo, right? This is kilo. 4 milliamperes. So which is greater than 0? Hence my assumption was correct that this diode D1 and D2 are on. Current is flowing from P to N and I am getting the current as positive. So that means my assumption was correct. Hence D1 and D2 are on. And if D1 and D2 are on, then it is not possible that this case will happen. Again, if I short circuit this and find out the current, I see IS negative because IS positive. Yeah, I will come out to positive, but I need I negative. Why? Because current needs to flow from P to N, from here to here, not from here to here, not from N to P, from P to N. And this is saying that current will flow from N to P, which is not possible for a diode. Diode is a unidirectional device. So I found out the current, that is 6.25 by 4, and I found out the voltage as well. Voltage is what? Voltage is V1 equals to V2 equals to 15 by 4. Now if you want to make a sanity check, right, if you are correct or not, what you can do is, you can see whether these are satisfying the equations here as well. So what is the current through here? Current through here is V2 by 1. V2 by 1. V2 is equals to V1, that is 6.25 or I can write it in terms of 4, that is 12.5 by 4. Current through here is 12.5 divided by 4 milliamperes. What is the current through here? What is the current through here? Current through here is again 10 minus 3.75, which is this 6.25 divided by 4. So this is 6.25 divided by 4 milliamperes. Now what I have computed that I is equals to 6.25 divided by 4. This is 6.25 divided by 4 milliamperes. Is it satisfying? Is the KCL satisfying? So here 6.25, here 6.25, totally 12.5 divided by 4, which is correct. it is satisfying the KCL. So whatever I have computed is correct. So you can make a sanity check as well, whether you have computed correctly or not. If this doesn't satisfy the KCL, that means you must have made some calculation mistake. So you can cross verify your answer like this. So yeah, I have computed V1, I have computed V2, I have computed I. Let's compute for this. The answer will be same. Why? Because D1, I have explained the reason that D1 and D2 are off. If they are off, they will be replaced with open circuit and the calculations will be same. What will the calculations? Like this. Okay, so like the last one was pretty simple, just you need to know a bit of tricks. So like it almost went on for 1 hour, but I hope in this 1 hour, right, I've covered very good questions of diode circuits. And like what my assumption was, you already have a good idea about diodes, just you struggle a bit in diode circuits. That's why I like this was an intermediate level lecture. This was not a beginner level, so I haven't explained everything from basics. I have started from intermediate to advanced, right? So if you are struggling with basics, you can go to our channel Prefusion. There we have complete playlist of diodes, and we have the full course of analog electronics on our website. You can visit our website and study from there. So yeah, thank you for watching this whole lecture. If you liked it, do hit the like button. Do subscribe to my channel for more videos like this.